Norway. So yeah, my name's Scott Vaughn. I'm the director here at the Center for an Ecology-Based Economy. We've been here now, as of Saturday, we've been here in Norway, Maine in this space for 10 years, working on climate action stuff. And as many of you know, pushing hard on electrifying our economy. And it turns out that lithium is going to be a big part of that. Before we get going with the webinar tonight, I'd just like to acknowledge that if you're in Maine, wherever you are right now, you're on unceded territory of the Wabanaki Confederacy. This lithium deposit in Newry is specifically in Abenaki territory, and most likely a band of Abenaki called the Arosaguntukuk, who were all driven brutally from this land, which is why we don't see any kind of Native American presence or reservations on this part of the state. And just before we get going, I'd just like to take a few seconds just to think about that and acknowledge that. So thanks for that. Yeah, so as I mentioned, CB's been pushing on electrifying our economy and decarbonizing our economy for the last 10 years and pushing on electric vehicles. And as many of you know, Maine has a very aggressive climate action plan in line with the global intergovernmental panel on climate change model for how we can avoid the worst effects of the climate crisis that are already upon us. If you live in Maine, I'm sure you're aware of that. As we see our winters go crazy and warming temperatures in our Gulf of Maine and our lakes, and a big part of the solution to this problem, at least in the near term, we're fairly committed to building an electrified economy that's largely built on lithium. So happy to have you all here to start this conversation. I'd also like to just mention that in 2.5 weeks, we're having our annual 2030 Vision Climate Convergence here in Norway for 2 days. It's the Friday, the 12th, and the Saturday, the 13th of May. We're meeting outdoors over at the rec park here in Norway on Cottage Street. And this conversation will be continued along with a lot of other conversations about how our region is going to adapt to the climate crisis, how we're going to regenerate our lands, how we're going to feed ourselves in this part of the world. Lots of interesting conversations about building an ecology-based regenerative economy here. So wanted to invite everybody to come. So as we get into this, I actually had the pleasure of working with Miles Felch. I'm a photographer by trade, and I took a lot of pictures of a lot of crystals at that museum, and talking about this. We've been talking about lithium at our EV Expo last fall. We started to really look at the lithium cycle, and like, who can we really get who's knowledgeable about this? And I couldn't think of anybody better than Miles. So Miles Felch has been working at the museum there for a long time. He's a curator there, and he's the staff geologist. And this is the Maine Mineral and Gem Museum in Bethel, which is 2 geology degrees, and he specializes in these granitic pegmatites, where what has made our region famous primarily for the tourmaline, but I think this lithium deposit may overshadow our tourmaline fame, at least in the short term here. So, and I also would just mention that Miles has been working on curating an exhibit on lithium that's going to open in the museum this fall. So I encourage you to get on the Maine Mineral and Gem Museum's mailing list and keep your eyes open for that. I'm sure it'll be fantastic. So without further ado, I'll introduce you to Miles Felch. Thanks, Miles. Thanks for being here.
Yeah, no problem. So yeah, just a couple thank yous real quick. So thanks, Scott, and the entire Center for an Ecology-Based Economy group for inviting me here to speak tonight. I've really been looking forward to this. I also want to give a big thank you to my partner, Lauren, who is taking on bedtime duty all by herself tonight with 2 kiddos. So big thanks to Lauren, is owed by everybody here. So so as Scott said, my name is Miles Felch. I'm a curator and geologist at the Maine Mineral and Gem Museum, which is located in Bethel, Maine. And here we showcase the largest display of Maine minerals anywhere. We also exhibit one of the most significant contemporary collections of meteorites. I started by saying that the museum is not a mining advocacy organization of any kind. So what I'm here to do tonight is present factual information regarding the lithium-bearing pegmatites that are found in Maine. And specifically, I'll focus on those located in the Newry area. I'll also provide some context for the long history of pegmatite mining that's gone on in the state, and I'm going to leave some questions, time for questions at the end for folks that you can get in over the chat session. Here on my intro slide are some snapshots from some recent articles that you've probably read. The initial reporting, though, of the Plumbago North deposit pegmatite, which is what the focus of this talk is really going to be all about. It was done by my colleagues here at the museum in 2020, and since then you've probably read the reports like you see on the right by Kate Koff at the Maine Monitor. She's done a great job there on reporting that. But with a little sleuthing in our museum archive,
Miles, you got yourself muted there. Accidentally.
all right, sorry, I don't know how that happened. But so yeah, I don't know where I cut off, but so this newspaper right here, the 30s, is about the Sterrett quarries in Warren, Maine. Like I said, they were discovered in the 30s, but they were really never developed. But they're located in coastal Maine, and so. But Warren is a long ways from Western Maine, so later in the presentation, I'll show you that there actually are a lot of clusters of these lithium-bearing pegmatites in the state, though they're all a little bit different. And also, before I get too far in, the slides are numbered, so if you have questions about a particular slide, you can reference those numbers as we go through. Okay, so some of the content in this presentation is from work that I and about a half dozen other colleagues have compiled from a bedrock mapping and exploration investigation that we completed through the Maine Geological Survey, as well as the United States Geological Survey's Earth Mapping Resources Initiative program. The later half of the presentation contains some content from an exhibition that I'll be developing about lithium, as Scott said, and that exhibit will be opening this fall. So it'll discuss more than just granitic pegmatites. But in this talk tonight, I'm going to provide some basic geological concepts, as I'm not sure if those of you who have tuned in tonight really have any background with that. And I think it's important to have some background when we're discussing this, any topic, but this particular topic that's at hand. So my goal here tonight is to provide you with a basic understanding of the lithium deposits in Maine, which means we're going to be talking tonight about granitic pegmatites, as they're the only source of lithium, and that being that source is actually a lithium-bearing mineral called spodumene. But before we begin talking about pegmatite, I think we really need to start with a little geology lesson. And so the next few slides are a fun little introduction to what rocks are. And so remember, in doing this, we're working our way up to understanding what granitic pegmatite is. And then we're going to discuss spodumene specifically. So let's get to the next slide. Class is in session here. So in order to understand what a granitic pegmatite is, we'll first talk about granite. And that should be a pretty familiar rock type to most of you. It was a rock that was and still is quarried in the state of Maine, but it was quarried extensively, not too long ago. And the reason I'm doing this is because there are compositional similarities between a traditional granite and a granite pegmatite. And as I'm giving this presentation after or during your dinner time, I figured sticking with food analogies is the best way to get my point across here. So we'll get down to basics. This is my simple little crash course to help explain what a rock is. And I usually reserve this for grade school students, but I find it works well for adults too. So at first, it might not seem like rocks and salad have much in common, but I encourage you to stick with me here. So a salad is an assemblage of individual vegetables, right? So this salad here contains 4 different types of vegetables, and each can be distinguished from one another based on their appearance, their properties, or their flavors. And if we were talking minerals, we'd call these diagnostic properties. And so on their own, they're all vegetables, but when combined together, they form a salad. And so this particular assemblage of vegetables yields this salad that we see here. If we use different vegetables, we'd end up with a different salad, right? Okay, let's try the same thing with a rock. In this case, it's a slab of granite. And granite, like most rocks, is made up of a combination of minerals. And so though some rocks can be monomineralic, composed of one particular mineral. But here with the granite, we have the important ones are a couple of different types of feldspar, microcline and albite plagioclase, as well as quartz is another important one, and as well as biotite in this particular granite. So rocks, like the salad, made up of vegetables, rocks are made up of a combinations of different minerals, and each rock is defined by the presence of a certain mineral assemblage, right? So this granite is just one example of what you get from a particular assemblage of minerals, and there are many other minerals out there and different rocks. Okay, so but circling back to pegmatite, the reason I chose to discuss granite again is before pegmatites is that most pegmatites are granitic in composition, so meaning they're primarily composed of feldspar and quartz, though they might have other phases like micas or garnet or something like that. Those are also commonly associated with granite. So really quickly, the rocks are salad introduction was done to illustrate that, again, rocks are made up of different combinations of minerals. And so this is important to note because different assemblages of minerals make different rocks. But it's also important to note that the weathering of those different minerals can be quite different. So when exposed to surface conditions, whether that's rain or air, so depending on what the mineral assemblage is, those minerals in that rock will interact differently. And so, for example, in granite, the minerals in the rock are primarily silicate minerals. And you see a similarity here with the formula. The silicon keeps constituents of the granite right here. And so that's when these minerals weather, they release ions in solution, sodium, potassium, sometimes silica goes as well. And then it will also make clay minerals as well. So, but that is different than a rock that contains sulfide minerals, which are, when weathered, are capable of producing sulfuric acid. And these are the types of minerals right here that can create acid mine drainage or acid rock drainage, depending on the scale of how much of the acid is being produced. And so here I'm contrasting the general bulk composition of granite, yes, with that of what we call a volcanogenic massive sulfide deposit, which are common economic deposits that are mined for copper, lead, and zinc. But so you'll note that there are some similarities between these two rock types. They have some similar minerals, but they also have some major differences. Of note is these common sulfide minerals that I put in here, and depending on the VMS deposit, there may be different ones. So, but let's get back to the pegmatite story now that we know what granite is made out of, right? So what is pegmatite exactly? Let's define that. Textural term that's used to describe a very coarse-grained igneous rock. And by that I mean it's a rock that is cooled and crystallized from molten magma below the surface of the earth. And the term pegmatite can be applied to many different rock types like gabbro or syenite, for example, but it's most commonly referred to granitic compositions. And so for the rest of the lecture, if I say pegmatite, I'm referring to one of granitic composition, which is why we covered that rocks are salad thing right there and at the beginning. So you remember what the minerals of granite are: quartz and feldspar, and then some micas. So most pegmatites are granitic pegmatites are composed of just those minerals. Just one other note about grain size, because pegmatites, life is not simple, right? The mineral grain size in pegmatites may also vary by several orders of magnitude. So they might not be entirely coarse. They might have certain units in them that may contain finer grained, what we call aplytic sections as well. So Pegmatites themselves are quite easy to identify in a field as these white kind of streaks across, whether it's metamorphic rock in this picture on the left or a host igneous rock on the right there. See the pegmatite, this white streak in the rock. And they can occur anywhere from a few feet thick to a few hundred feet thick in width. Excuse me. And in some cases, in other parts of the world, they're up to a mile thick, but nothing to date has been found that large here in Maine. And to wrap up pegmatites here, they commonly also host a range of mineral species that have value as either specimens, gem rock, or as ore, as we'll be discussing today. To get kind of in the weeds here, there are different categories of granitic pegmatites. So the traditional classification scheme has separated more or less into 3 basic groups based on the presence or absence of certain mineral phases. The most common are the barren types, which most people encounter when they see a pegmatite on the last slide. Those are 2 examples of barren pegmatites. And so the mineralogy in those is very simple. It's granitic. You have 2 different types of feldspar, quartz, and sometimes muscovite or biotite, maybe some garnet, maybe some schorl tourmaline on occasion. But the 2 other categories, the 2 next categories, they kind of branch off from that traditional granitic composition. That's where you start to see some other really interesting minerals show up. And so the 2 groups are acronyms: lithium, cesium, and tantalum, because there are minerals that contain either lithium, cesium, and tantalum in those pegmatites. And then the next are the NYF, and that's niobium, yttrium, and fluorine. Again, there's mineral phases in these types of pegmatites that contain those elements, as well as others that aren't listed here, but those are the most common given that classification scheme. And so I'll note here that this particular classification scheme with these 2 acronyms is kind of on its way out, as there's been a newly proposed classification method published last year. And so, but I'm presenting it here because if you go to do your own research, you're likely going to encounter these acronyms, and that's what they mean. So all of these different types are found here in Maine, but the most common are barren, and then followed by the lithium-bearing pegmatites. Now, lithium-bearing pegmatites are very commonly associated with a region that has experienced a mountain building event, what we call an orogeny. And here in Maine, we have a mountain belt, right, the Appalachians. And so it makes sense that you might find some pegmatites here. And that's not to say that everywhere you see mountains, you're likely to encounter lithium-bearing pegmatites, at least not at the level that they're eroded. They still could be located at depth. There are 2 leading models for the formation of pegmatites: fractional crystallization from a larger volume of granite, and you get these kind of offshoots. So they represent the residual melt of a larger volume of magma. But also, the other leading theory too is partial melting from some pre-existing rock, what we call anatexis. And there's a lot of evidence to suggest that Maine's pegmatites form in this way. They have certain characteristics that might suggest that, and of course their relationship to the surrounding rocks. But either way, all pegmatites form below the surface. And so that's what this graphic here is illustrating. There's the surface, and at depth, you see on the y-axis going down here, at depth is where these things form. So where exactly are pegmatites located in Maine? Well, there are thousands. Them in MDI, you can find them further inland in Lincoln counties, Penobscot County. You can find some in Lincoln County as well. They are just all over the place. And even though there's, and you commonly see them along road outcrops, like on road cuts on the side of the road if they've blasted there, or even in coastal outcrops like you see in this image right here, these white streaks. This is nearby Reed State Park. A nice aerial shot of the white pegmatite cross-cutting the regional metamorphic rock. But although there's thousands located throughout the state, there's a belt of pegmatite deposits that extend from the Georgetown, Topsom area, and they extend up into Oxford County. And highlighted in this map in blue are just some of the more well-known pegmatite quarries in the state. Now, the state of Maine has a long history of pegmatite mining, which began in the mid-1800s. And it really first developed along the coast of Maine, and then later in the Auburn area. Oh, excuse me, I'm getting ahead of myself here. The pursuit for the reason they were quarried in the first place was for feldspar, right? But I'll note that many of the pegmatite deposits that were quarried for feldspar also contain lithium-bearing minerals like spodumene, okay, which would have been cast out onto the dumps because they weren't looking for the spodumene, they were looking for the feldspar. And so, but there were feldspar mills that were created in the state to process the feldspar locally from the quarries, and these were first developed along the coastline, and then later in Auburn. And the mill in Auburn, which it was supplied by a series of pits in the area, and including a series that are in what's called Mount Appetite Town Park, and today these are collectively called Mount Appetite East. These different pits there, and again, though these were quarried for feldspar, they also contain spodumene. At least it's reported that they contain spodumene, and there are plenty of minerals that have popped up in the collection here to suggest that there was definitely spodumene mined at this particular location. Or excuse me, it was definitely within the pegmatite at this particular location. And so, even though they were quarrying, there was spodumene there, but altogether in Mount Appetite State Park, there's about 3 acres of abandoned pits, and there's a really thick tailings pile that's about 3 acres wide that's been sitting there since mining ceased over 50 years ago. So I just thought I'd mention that because there are lots of abandoned pegmatite quarries and their tailings in the state. And so this is just one example of this. But the last feldspar mill to open was in West Paris. I'll just kind of that right there. And this is really important for unlocking the region of Western Maine pegmatites in Oxford County, and it allowed for them to be quarried. And so you can see how many quarries there are in this small area of Greenwood, West Paris, Albany. There are a lot here, and this does not include the Newry quarries, which would be to the north there. And these also supplied feldspar. And just a little factoid too is that a report from 1968 on the Newry quarries, among others in that report, estimated that by 1968, the quarries at Newry had supplied over 4,000 tons of feldspar and 250 tons of spodumene as well. There were other mineral phases that they also had listed in that report. So that's a Barton and others report, 1968. So Beryllium Investigations report. Okay, so before moving fully into the Earth MRI project summary, I wanted to go back to a point that I made at the beginning of the presentation, that there are many pegmatites in Maine that contain lithium minerals. And so here's a map that highlights some of the geochronology or age dating that we acquired during the course of the research project that I'll talk about in a moment. And that really helped us to understand how Maine's lithium-bearing pegmatites fit into the regional geologic framework. The New Hampshire border on the left side, there's the ocean in the southeast, and I've actually highlighted Norway, Maine for context there. But like I said, I wanted to use this to illustrate that there are many different lithium-bearing pegmatites in Maine. So they appear as clusters, or what we call a pegmatite series, along the coast. You have Appleton, one in Appleton, or several in Appleton and Warren area. Androscoggin County, which is not highlighted here, would have the Havey, Mount Appetite, east and west quarries as well. In Paris, you have, of course, the famous Mount Mica. The Emmons would be in the Greenwood series. BB number 7 is also included in that, Harvard, Tammany. And then the Newry series, or what's actually called the Rumford series in the literature, would be Plumbago North, Crooker, the Dunton, others around Plumbago Mountain, and that includes also Black Mountain across the river. And then we have Bemis Stream and Brimstone, all at the top here, actually in Franklin County. So there are clusters of these lithium-bearing pegmatites that are stretched across 5 different counties. And interestingly, based on our preliminary age dating work, we found that each of these series formed during a different period in Maine's geologic history, independently of one another. So, and that spanned about 100 million years. So that's pretty interesting. So, but all right, so we've learned a little bit about rocks and granitic pegmatites in the state. And so let's segue into a summary of the Earth MRI project that I mentioned. And then we'll talk specifically about the geology and history of lithium-bearing pegmatites in the Newry area. Okay, so our group listed here undertook this arduous task of mapping the bedrock in the region by literally trudging through the woods and observing and documenting bedrock outcrops that we encountered to create this map right here. This was one of the deliverables of this particular project. And there will be a report that's coming out on that soon, hopefully. It has been submitted and it's being reviewed right now. The map and others like this is just a bedrock map, but there are surficial geologic maps, surficial materials maps, and other maps like that. They're all free, available free to the public through the Maine Geological Survey, their website there. You can download the PDFs, or you can pay a fee and have them print one and mail to you. So that's just something for you to know when you're coming away from this tonight. So apart from this map, the project was done also to test some exploration techniques that have been utilized elsewhere in the world for locating potential unknown lithium-bearing pegmatites in a region. And what some of the things that we did include analyzing the geochemistry of muscovite and feldspar from some of the granitic pegmatites in the field area. We also sampled and then analyzed stream sediments to see if there were any geochemical indicators that might allow someone to then locate unknown lithium deposits. And we also conducted several geochronology studies. And as you saw on the last slide, one such study was done to date the lithium-bearing granitic pegmatites in the state. And we use cassiterite, which is a tin oxide mineral that you find in most lithium-bearing pegmatites, although it can be kind of tricky to find at times. And so, but just to clarify too, because I don't think I said this on the last slide, geochronology work, it provides us with something I've been saying, ages of rocks. And so what this means is that we can infer within a margin of error when an igneous rock crystallized, and so when it formed. And this is significant because it allows us to look more broadly at the regional geology and develop a kind of a sequence of events as to what happened, what formed this particular landscape that we see here. So here's a close-up of the map that we produced specifically around Plumbago Mountain. It's kind of this long ridge right here, Plumbago Mountain. It's the high point. And the different colors that you see on the map represent different types of rock. Okay, and again, this is kind of a game of connect the dots as you're walking through the field, because if anyone here has spent any time in the woods of Maine, which I'm sure most people on this call have, you know that there's a lot of overburden, there's sediment, and it's heavily vegetated. And so you're literally going along and you find one outcropping of rock, you note what it is, you walk till you find the next, and then like you connect the dots and you fill in this area with what you believe is the best representation of the bedrock below the surface that's covered with sediment. All of the lithium-bearing pegmatites here are mapped in red as PLCTP, and that again, the lithium, cesium, and tantalum pegmatite. P is Permian. That's the age in which when they formed. Let's see. So we determined in the field whether or not a pegmatite was lithium bearing based on whether or not we saw a lithium phase in the outcrop like spodumene, lepidolite, monobracite, elbaite, or if they had been previously mapped to contain lithium, because this area had been investigated before we came in here. So there are quite a bit of this map. It's not just all of our work, it's a compilation of work that had been done previously in the region as well. We can't take all the credit there. And you'll notice that with the red here, there's quite a few different, lithium-bearing pegmatites that surround Plumbago Mountain, but none of them, based on the field observations that we made and from previous work that was done in the area, are as enriched in spodumene as the Plumbago North deposit, which is located right here in this north-facing notch on Plumbago Mountain. Though some over on the east side and up on the north, I would say, do contain some noticeably large volumes of spodumene, based on those are the exposures that we saw today. You know, if you were to go out there today, you'd see that there's spodumene around. So, but none are as enriched as the Plumbago North. Now, the pegmatites, the lithium-bearing pegmatites here are around Plumbago are hosted by a couple different types of rock, depending on, and that's depending on where they're located. Plumbago North on the west side here is surrounded by this blue. This is it's a metamorphic rock that is hosting the pegmatites here. And it's a metamorphic rock called a schist. And schist is a really common regional metamorphic rock that you find here in Maine. It appears to have layers, or more accurately, we call that foliation. So kind of a layering of the micas in there. The biotite and the muscovite micas may contain more or less of those two, or one particular phase dominantly. But it also contains quartz and feldspar, garnet, and there's many other minerals that can be found in the schist. And in some parts of the state, this rock is actually blasted and used as an aggregate. But on the north and eastern side of Plumbago, the lithium-bearing pegmatites here are surrounded by either a gabbro, and that's this purple right here. And a gabbro is another type of igneous rock. So igneous rock, again, like granite, it cools and crystallizes from a molten magma. And so, but it's gabbroic in composition here. And then some of them actually intrude this very odd metamorphic rock, what we infer to be a metamorphosed volcanic rock at this time. It's in this darker green and actinolite schist that's very unique for the whole region. I don't think that there's ever been a rock quite like this reported from elsewhere in Western Maine, at least not to my knowledge. I also want to note these yellow blebs here in these topographic highs along these ridges right here labeled PCP, and that's Permian, again, the age in which they came, we infer they came in. And a common pegmatite would be a barren pegmatite, one that's really just granite in composition, the feldspar, quartz, and then there's some mica. Now, pegmatite like this, you know, they're kind of capping all the hills. You find that a lot of the hills and the mountains in Western Maine here are capped by granitic pegmatite. And just an example, right across the Ellis River here is the Rumford Whitecap, which is a really popular hiking destination, some of the best views, I think, in Western Maine. But it's almost entirely composed of granitic pegmatite, and it's been exposed and is weathering out there, and has been weathering out since the most recent glaciation, just we'll say 10,000 years ago here for this. Okay, so here is another slide that is of the field area. Again, Plumbago Mountain here, here's Plumbago North, but it's really focusing on the different quarries that you find in this region. And it's from a website, Mindat, which if you haven't looked at, you should check it out. It's the premier world-wide reference for mineral localities. And I really recommend taking a look at it. But you'll note that there's a high concentration of quarries located within the pegmatites that intrude the actinolite schist, that weird metamorphic rock that I was talking about, what I've called the Newry Hill quarries. So there's a high concentration of them here, and also some on the northern part. And then there's just this one Plumbago North over the side. And we found one more during this field investigation to the southwest that hadn't been discovered in the past. All right. So here's a shot of Twin Tunnels, which is a feldspar quarry on the east side of Plumbago Mountain. And this to the right is a very abbreviated list of some of the minerals found at the different Newry quarries. There are many more minerals that are listed that are not listed here, but I've highlighted in here the ones that the minerals that contain lithium. And I felt like showing this list is important because it illustrates the diversity of minerals that one can encounter in these types of deposits. And so according to Mindat, back to that, and there's over 100 species at the Dunton Quarry that have been identified at the Dunton Quarry alone. 100 different mineral species in one rock type. That's just incredible. You know, for perspective, most common rocks like granite, schist, basalt, they host maybe up to 12, maybe 15, the most when you count all the micro sub-millimeter scale accessory mineral phases there. So, but the bulk composition of these pegmatites, though, is still granite, feldspar, and quartz. And so let's move on. The most famous pegmatite around Plumbago Mountain, at least until Plumbago North came around, is the Dunton Quarry. And so here's where this really fabulous and historic find of gem tourmaline was made. And the gem tourmaline variety is elbaite. And I note that elbaite is a lithium-bearing species of tourmaline. Okay, but this discovery was made in the fall of 1972 by several amateur mineral collectors. And the crystals themselves, we see here, this is one example, were recovered from what's called a pocket. And so this is a solid, void, excuse me, in solid rock. And it occurs in some of Maine's pegmatites. Maine's state mineral is tourmaline, right? And so in some pegmatites in Maine, you find that there are these voids in solid rock. And if you're lucky enough, you might find that there's tourmaline in there. And so there were actually a series of pockets that led up to a really significant find. The last one here, that you can see the entrance, it was about 5 feet wide by 5 feet tall, and it was about, all in all, almost 30 feet long in length, which is just really a really big void. And it was just full of this type of tourmaline right here. That was essentially it, and rotten Clevelandite. But the crystals themselves are very characteristic coming from this find. You have really steep terminations, oftentimes bicolored blue and green. If they're cut in cross sections, sometimes you get this nice watermelon tourmaline, this interesting zoning phenomenon that occurs here. You get red in the center and green on the sides. And so if you're a really big serious mineral collector worldwide, and no matter where you're at, you know about this famous find in 1972. And if you don't have a crystal, you certainly want one in your collection. But interestingly enough, no pocket like it has been found since in any of the new quarries. And that's really not to say there has been a lot of people that have tried to find that proverbial needle in a pegmatite haystack, but no one has uncovered a pocket quite like this again. So it's the single largest discovery of gem tourmaline ever in North America to date. And so quickly referring to some of the photos here, you see that we have this entrance to the cavity with a little red radio flyer wagon. One of the miners here borrowed this from their child to load up with tourmaline when they were in the hole and then send it out. Yeah, so, and I've already mentioned the other photos here, so we'll move on. But as I mentioned, this was the single largest discovery of gem tourmaline ever made in North America at the Dunton Quarry. And so I've inserted this image right here for context. So we note the burlap sacks and the boxes lining the entrance to the pocket there. These are filled with tourmaline crystals wrapped in newsprint. So that's pretty remarkable. So it's been estimated that over a ton of gem tourmaline, was recovered from this single find. Okay, but enough about tourmaline already. Let's talk about what might be the next chapter in Nuri's pegmatite quarrying history. And this would be the Plumbago North pegmatite, which contains, as we mentioned, spodumene, which is the leading hard rock lithium-bearing ore mineral. Spodumene is a mineral that's found, like I said, in many of the Nuri quarries in the area, but it is very abundant here at Plumbago North. And so we have Bates student Evan Saltman. I think he was on the call. Shout out, Evan. Thanks for tuning in. We have these spodumene crystals. They're just everywhere. These elongated things. There's one up at the top, one coming down. They're just everywhere. And the crystals are really world class. Some of them have reached lengths of up to 33 feet in length, which is just remarkable. And so according to the United States Geological Survey, over half of the world's lithium resources are derived from spodumene. And that's spodumene, again, from granitic pegmatites. And at this time, most of that is coming from Western Australia. So that will likely change as projects in Canada and South America and maybe other parts of the US, like in the Piedmont district, may begin mining and quarrying for the spodumene there. But it's currently the fastest way to bring lithium products to market, faster than brines through the traditional evaporation pond method. Okay. But here are, let's see, 4 examples of spodumene that are on display actually at the museum in the main Minerals A to Z gallery. Spodumene group. And for main pegmatites, it's commonly a buff white color, but may also appear as this pinkish, or sometimes they're a light green crystals that show up, not true hiddenite like what's coming in, what has come out of North Carolina, but they'll have kind of a greenish appearance to them, pink being the kunzite variety. It commonly occurs in the matrix of pegmatites, like what we see right here. So it's just interlocked with other minerals. In this case, it's mostly a lot of quartz and some albite feldspar, as well as some muscovite. But it can also occur as gem crystals in pockets, though this is really, really uncommon in Maine. And actually, I'm pretty sure there's only one location that, at least that I know of, in Georgetown, Maine, where there were kunzite, light pink spodumene crystals were recovered from pockets there. But there are better examples of gemmy spodumene crystals that can be seen from pegmatites from Afghanistan or Brazil or San Diego, California, locally, in the US. All right, so as I mentioned earlier, my colleagues here at MMGM were the first to characterize the Plumbago North deposit, and part of their work included a comprehensive list of the minerals that were found in this pegmatite. And these geologists, what they did was they collected samples from the field, they made observations within the exposed pit, and they reviewed 23 cores that were taken from this deposit to arrive at this list of mineral species. And they included everything that they found in hand samples, as well as what they also obtained through heavy mineral separations, which is where you take a bulk sample of rock and you crush it up and then sieve it and sort it out to find the tiniest of mineral phases. And so the majority of the accessory mineral phases that you see here, the majority of them are on the centimeter to millimeter scale. They're very, very small, the majority of them. So let's briefly review the mineralogy of the Plumbago North deposit as it's reported from the Simmons and other publication. So we tally up the bulk, we call the major minerals, the bulk mineralogy here, we see that 96% of this rock is composed of silicates, quartz, albite feldspar, spodumene, again, a silicate mineral, aluminosilicate mineral, and muscovite, also a silicate, okay? And the other 4%, all of these accessory minerals here, is comprised of 20 different minerals. And as some folks have recently and astutely pointed out, this deposit contains sulfides, and not just galena, the lead sulfide right here. There's also sphalerite, we need to point out as well. But like many of the accessory minerals on this list, the sulfides were found in this example here. They were found on the millimeter to millimeter or sub-millimeter sized grains, derived from the bulk, the heavy mineral separations. So my colleagues here were doing their due diligence when they did this, and they report everything that they can find. But again, these sulfides right here are estimated to be less than 0.001% of the entire pegmatite body, an extremely small fraction of the entire rock, okay? And, you know, there have been some larger masses of sphalerite reported from some of the other newer pegmatites, but they still make up a very, very, very small portion of the entire dike, okay? You can even find these sulfides, if you look at some of the granite quarries in the state of Maine, you can find trace amounts of these sulfides at the same scale, generally the same ratio, at some of these, at some of the granite quarries in the state, okay? So if we look at other lithium-bearing pegmatite minerals worldwide, we see that they commonly contain sulfide minerals, all right? Not just silicates. But it's these sulfide minerals, they always make up way less than 1% of the entire host rock, and there's almost zero chance that they'll ever contain more than that. And I'm speaking specifically about lithium-bearing pegmatites here. That's what I'm talking about today. Remember, there were other different types of pegmatites, but lithium-bearing ones. So here's a complete list from one of the largest and oldest known lithium pegmatites in the world, the Tanco, which is in Manitoba, Canada, where they have mined, among other things, spodumene, pollucite, as well as lepidolite and other things. So different lithium minerals and a cesium-bearing mineral. But there's a total of 98 different minerals here, and 8 different groups of minerals: sulfides, native elements, phosphates, sulfates, borates, carbonates, etc. So the oxides, there's a ton of different minerals here in this one pegmatite. But again, just noting that the bulk composition is going to be granitic, and then these other minerals make up a very small percentage of the entire host rock. And so there are, and I'll just note one other thing, there are numerous lithium-bearing pegmatites around the world that are being mined for lithium minerals currently, and have been in the past. And even though they contain sulfide minerals, there has never been a report of acid mine drainage from any of these. Okay. So now let's look at how the Pegmatite North deposit compares to other pegmatite deposits worldwide. So first, we need to note that the ore estimates from the Simmons and others 2020 report on Plumbago North, they were done on 2 independently analyzed bulk samples and some targeted coring around this deposit, and that really more exploration needs to be done to reveal what we would refer to as proven reserves. Okay, so more needs to be done on that. But here we have a log plot where we have the concentration of lithium oxide on the y-axis here, and on the x we have the ore reserve estimates in million metric tons. And so again, based on 2 independently analyzed bulk samples, the Plumbago North deposit contains the highest average lithium concentration for spodumene, for any spodumene bearing pegmatite, at 4.68. Anything that's reported, this is the highest that is on record here. 4.68% lithium oxide for the 10 million metric tons of ore that it contains. And so though this volume of 10 million metric tons may be lower than some of the other pegmatite deposits worldwide, for which this data, these are all different pegmatite deposits in different parts of the world, some in the US, others in Canada, and then some in Western Australia. But even though the volume may be lower, because again, the overall volume of ore in million metric tons is quite low compared to some like at Greenbushes or Mount Marion or the Wabauchi in Canada, we see that because it has a higher grade, it actually makes it quite comparable to other deposits with much higher volumes. And so that's what these diagonal lines represent right here. So lines of equal amount of contained lithium oxide in this case, in metric tons. So along these diagonal lines, these are comparable overall tonnages. So the Plumbago North, it has really high overall weight percent of lithium oxide, but low ore compared to others that have a higher volume but a lower grade, but still they're quite comparable. Okay, so before switching gears to discuss the different types of lithium deposits, and I'm trying to check time, I'm kind of going way over here. I just wanted to quickly discuss the different types of lithium deposits that, excuse me, the different, the basic steps for extracting and creating a marketable battery grade lithium chemical from spodumene. So there are various papers in the literature on this that cover these steps in way more detail than I'm going to do here. And you also can get into some alternative methods, but I'm going to be talking about the most conventional method that utilizes a sulfuric acid wash. And so the first step for extraction is to blast the solid rock with dynamite, see here, and then you separate it out in a series of processing techniques, what you call benefaction. And this could include just coarse sorting on site, where you're breaking up the rock and kind of separating certain parts. And that's what's interesting about the Plumbago North deposit compared to others, is that the spodumene is so large, it's quite easy to separate the material, whereas other pegmatites, for example, Greenbushes, the spodumene crystals are very small at times, or even in the Carolinas, the spodumene there, some of the crystals are quite small, so it might require additional screening or flotation to really just further concentrate the spodumene. So, but once you've been able to concentrate the spodumene to a certain percentage there, it's ready to be processed. And so spodumene, as it's found in granitic pegmatites, crystallizes in the monoclinic crystal system. And so this structure has to change, though, in order to flush out the lithium efficiently. And so the ore is roasted at high temps to convert to beta spodumene. There's nothing added to this other than the spodumene is added and roasted. Okay. And so it's converted to beta spodumene, which is in the tetragonal crystal system, and it's a less densely packed material, and it actually breaks up the material, so it's really fissily in this process, and it makes it more amenable to chemical attack. And so, but the process of roasting and heating up the spodumene in the furnace, it's a little over 1,000 degrees Celsius to do this. And again, there's no chemicals added in this particular process. But in the next stage, we add sulfuric acid to the beta spodumene, and we roast that to about 200, 250 degrees Celsius. And that's not 2,000. I've been hearing that a lot recently from folks. That's 200 to 250 degrees Celsius is the sulfuric acid roast, not 2,000 degrees Celsius. And so what this does, though, it creates a water-soluble lithium sulfate that, there's excess sulfuric acid that can be neutralized in this process. But that water-soluble lithium sulfate is what that material is used to further concentrate and mix with other compounds to then create lithium carbonate. In this instance here, though, that can be further converted and is often converted to lithium hydroxide, which is another precursor battery material. The difference is that it's specific to whatever the cathode type is. It's going to require this, whether it's lithium carbonate or lithium hydroxide or chloride or whatever it is. And so I'll note here, though, before moving on, that the majority, again, the majority of the world's spodumene is currently being processed in China, which would disqualify that material, no matter if it's from a free trade agreement partner like Chile or Australia, from any of the benefits that are set out in the Inflation Reduction Act, because it is processed in a foreign entity of concern, that being China. Okay, just want to point that out. So we'll briefly here, as we're wrapping up, cover some of the current lithium resources in the world, and I'll explain the differences between these deposits. And so this is an excellent map that was created by the British Geological Survey, and you can actually visit their website for the complete graphic that actually names these different types of deposits that are listed on the map. But and note that there are more that have been identified since this map was produced. It doesn't include all of them that are out there. But it highlights the important ones here is pegmatites and some granites in some cases, volcanogenic and sedimentary deposits, as well as the brines. And they break the brines up into a couple different, whether they're continental brines or they're geothermal and oil field brines. Okay. So here's some images of the big three lithium resource types. Hard rock spodumene deposits are at this time the world's largest supplier of lithium products. As I said, over half of the world's lithium is derived from Western Australia granitic pegmatites. And the contribution from Western Australia is going to expected to really remain quite high later into the half of this decade, because it's taking a while for a lot of the brine projects to come up online. But here photographed is the Greenbushes pegmatite of Western Australia, and that's this white streak. That's the pegmatite. The rest is all overburden. That's what we call country rock. Okay, this is the largest granitic pegmatite quarry in the world. And I'll note that Maine's pegmatites are nowhere near the size of what we see here in Greenbushes, and the mining regulations here in Maine would never allow a pit this size to ever exist. But I just wanted to show you for perspective, this is what's going on in Western Australia. The brines, at least those originating in the salars, these are high elevation arid regions in the Andes right here, in the South American countries of Argentina, Bolivia, and Chile. Together, these are referred to as the lithium triangle. Maybe some folks have heard that before. They contain the largest known global reserves, but they currently provide less than half of the world's lithium resources. And most of that at this time is coming out of operations in Chile, which have like the largest reserves of all really world-class deposits, although the Salar de Uyuni is quite impressive as well. But I don't know if Bolivia is going to be taking part in this supply chain anytime soon. There are many projects in Argentina that are going to be coming online by the end and the middle of this decade. But the process for extracting lithium here in these deposits is fairly simple. We're in high elevation salars. These high elevation deserts right here. You see the mountain range in the distance. So there's just kind of mountain ranges on either side, these flat basins. And it's in these enclosed basins, the groundwater here, it's a brine. It's very, very salty water. So the basins are all filled with salt, among other things, and other sediments. But it's the groundwater is enriched with lithium. And this is not potable groundwater that you're thinking of, like I'm going to go drink from the tap. This is very salty, like hyper saline water. It would kill you if you drank too much of it. But the groundwater is enriched in lithium, and you pump it up into one of these. In most of these operations, and this is just traditional, I'm talking about just traditional evaporation. There are other technologies out there called direct lithium extraction. Maybe we can take some of the questions about that later. But here the sun evaporates, and what it does is it concentrates the brine, so it gets increasingly more enriched in lithium, and it precipitates a lot of the impurities out. Okay. And so again, I wanted to repeat something that I mentioned just moments ago, though, about Chile and Argentina as free trade agreement partners with the US. Okay, just because they're free trade agreement partners with the US, that does not in any way guarantee that they're going to sell their lithium products to be processed here in the US. Okay, and so again, the majority of that is processed in China. That will change, I think, over time, but therefore, again, it disqualifies that material from the guidelines and the subsidies that are defined by the Inflation Reduction Act. I think that's an important thing to point out, okay? But the clays that are quite rich in lithium have been really making a lot of press here, at least in the US. So in Northern Nevada, the Thacker Pass location will likely be an important supply of domestically sourced lithium in this decade. But I'll note that this resource has essentially been claimed by General Motors for the foreseeable future. So where General Motors is getting its lithium, among other places, will most likely be from Thacker Pass. And that's not Tesla, that's not Ford or Rivian or Chevy. That's one US automaker. There are many other automakers out there. Where are they going to get their lithium from? Especially if they want it to meet the IRA's subsidies. So just wrapping up resources, I got 2 more slides here. So wrapping up resources, I wanted to include another graphic that illustrates resource potential, but this includes the pegmatites, the clays, as well as the brines. And so remember, in Maine, the only lithium resource is granitic pegmatites. Remember that. So the axis here in this plot, they're essentially the same to the previous plot. It's just over here on the y-axis, we're not doing log scale, and it's also in lithium metal instead of lithium oxide. And that's for those of you who are going to do your own research after this, just keep that in mind. Just be cautious that different folks report on different types. So there's lithium metal. Sometimes it's reported as lithium oxide, which it was previously, but also lithium carbonate equivalent is generally the go-to that a lot of people use. But there are some nice handy conversion factors if you want to figure out what the difference is. There you can find that. So, but it's worth noting here that pegmatite deposits generally have quite higher grade in the blue circles, generally have higher grade, but they have overall, at times lower volume of material, whereas in some of the salars, you have very, very high volumes at a very low grade. So this is a lower concentration, in this case, of lithium metal for the overall volume. Okay, so higher concentration of lithium. And if we were to plot Plumbago North, it would be at 2.175 weight percent lithium metal. It's plotting right around here, and it would be off the screen up at the top. Okay, so wrapping up here, I just want to take a brief look at Maine's current metallic mining law and how it affects quarrying for spodumene in the state. And so according to the legislation, a metallic mineral is any ore mineral that is excavated for its metallic mineral content. And then to be used for commercial or industrial purposes. And interestingly, it doesn't include thorium or uranium of all things in this, but and this is really where the confusion lies for a couple of reasons. This metallic mineral definition here, and like I said, there's a couple of reasons why this is kind of confusing. I think it's because it's purely a definition that's based on policy and not really what's agreed upon in the scientific community as far as what a metallic mineral is. So it's open to interpretation, right? So a metallic mineral is one that, according to like an introductory geology course, what you learn in geology and what a geologist would think of in terms of metallic mineral is one that has a mineral that has metallic luster, or it exhibits some metal-like properties. Okay, but again, with this law, what it's doing is it's defining a metallic mineral based on the potential end use of that mineral, and that by using metallic mineral, that's what it's doing. Okay, and so the majority of the 5,000 plus minerals that are known to exist contain metals. And so, what are metals exactly? If we take a look at the periodic table. More or less anything in red, I say more or less, anything in red here is going to be a metal, and so therefore the majority of elements in fact are metals. And so if a mineral contains anything in red here and is excavated for commercial use, it's a metallic mineral, right? So that would really include things like the mineral calcite, which is quarried in Maine's coastal marble belt. Okay, calcium being metal here in group 2, but it also might include sand and gravel, which might contain garnet and iron-bearing aluminum silicate, or biotite, or muscovite, or feldspar, because one of those would be used because you would be using metallic minerals in that case for commercial purposes. So this is where it's a little interesting. And so, but as it regards to spodumene, utilizing a geology definition, it's not a metallic mineral. It does not have a metallic luster or exhibit metallic properties. But as it regards to its end use, its commercial use, the truth is that there's a really large market for lithium, not just lithium-ion batteries. It's used in grease, air filtration, pharmaceuticals, and so it's used in the form of lithium chemicals, different lithium chemicals. And so it's not solely for its metallic mineral content. The glass and steel industry, even the aluminum industry, through the manufacturing process, they might even just use spodumene in its raw form, just quarry the spodumene, crush it up, and then add it to a molten mixture there to reduce the melting temperatures and therefore reduce the operating costs of that whatever that business is there. If you're continuously casting steel or something like that, lower that melting temperature, lower the overall energy that needs to go into that. And so in that case, it's not even converted to any kind of chemical or reduced to the metal. So I'd say that the state has some hard decisions here to make in this next legislative session. So what we'll do is take questions through the chat. I believe it's going to be moderated by Scott, and I've left my email here for anyone to reach out to me with further questions. I'm sure I didn't cover everything and won't cover everything in the Q&A. So let's keep the conversation going. I just want to make sure I'm here to help point you out to different resources so that you can kind of come to your own conclusions about things.
Well, thanks so much, Miles. That was fantastic primer on how this all plays out, what lithium is and what that deposit is. And you should know Carl Francis has been on the chat answering some questions along the way, another expert from the museum. And there really aren't, so far, I think you've done a great job, and not a lot of big questions. They're starting to come in now. Early on, somebody asked, and I'm not even sure what this means, but they had a question about, oh, no, I can't find it. Graphic, where's that now? Maybe way up top here. Sorry. Well, let me go to another one, and I can stitch back to that. So someone has asked if folks have assessed to the degree that you've assessed what is in the what is in the mine here, or what is in this deposit, what the impact of mining would be on the landscape and everything that lives there.
Not to my knowledge. So like an economic or a environmental impact statement.
Right.
No, I think that's something that, and I don't, I'm not a mining expert here, but I believe that's something that really comes out when the reserve is proven and you can, so that you're going to start mining it. That's when you actually want to put out something like that, or that you could be mining it. But again, I'm not a mining expert here on this process, so. But no, I have not seen anything like that.
So that would be
published.
done once the,
I don't quote me on any of that. So I think it would need to be done here in the state, obviously.
but
But
only.
when that happens in the sequence of events, I'm not sure.
Right,
And as to my knowledge, it has not happened yet.
okay. There was a question about if lithium deposits have been found in New Hampshire, and Carl said very unlikely.
Yeah, there are some out there, but they're definitely not to the magnitude as you see here at Plumbago North.
So you and I have talked about this, about processing. Would there be plans to process this in the spodumene in Maine or transport it elsewhere?
So that's a loaded question because what do you mean by processing? My guess, just my guess, is that there would be like a coarse sort because you want to try to get as much of the spodumene off as possible without including any of the other minerals that are not desirable, right? The quartz or the feldspar. And given that the spodumene at Nuri is extremely coarse, that can make that job quite easy. But processing like flotation, I don't know, and I don't think so, but I don't know.
I think we're probably referring to that part where you're roasting it with sulfuric acid. And
okay, that part of processing, no. So that would require creating a whole plant, which I just, that's a whole nother set of regulations that I don't see that happening here at all. Not when there are other operations that are already in process, like the processing facilities are already either being built or operational in other parts of the world. So
yeah, that's come up a few times here.
sure.
I know you're not a
Yeah.
mine expert, but folks are asking about like what would be required to reclaim the site if it was mined under Maine mining regulations versus quarrying regulations.
Yeah, I don't know. That would be a better question for someone at the DEP.
Yeah. Yeah, I had a feeling a lot of these questions would come up, and
it's good. They're good questions.
Yeah, they're great questions, and you're a geologist and not a mining expert, like you said. And we are just kind of beginning this conversation, and these are conversations that are going to be happening across the state.
Yeah,
let me see. Somebody was asking about undersea deposits of lithium.
I have not heard of undersea lithium deposits, but I have heard of, so there's different types of mineral deposits in deep ocean settings. So nodules, ferromanganese nodules that can be rich in cobalt, nickel, among other things, as well as the iron and manganese. Then there's also kind of like these crusts that are kind of similar you might find. So there's a really cool magazine called Elements magazine that has topical issues, and they did a whole issue on deep sea mining that if someone wanted to know, I would definitely recommend checking that out as a good basis to start that learning about undersea deposits and what people are doing in that world or not doing.
So back to Maine, a couple of questions. One was, or do you know of any deposits that are on indigenous reservations, any of the tribal lands in Maine?
No.
No. And somebody asked if pegmatites are so prevalent in Maine, is the Nuri site potentially just the beginning? Is technology making it easier to identify these deposits?
Oh, that's a good question. And so the deposits are quite small. So when we did our work with stream sediment analysis, we thought that we would, maybe see it, because it's whatever's exposed at the surface, right? You know, we thought that we might see some potential for like, oh, maybe there's a potential lithium pegmatite here, there'd be a geochemical signature, and that wasn't the case. And there's a few reasons why that method didn't really work, but it seemed to be kind of boots on the ground was the best method. But you note that in the map I showed that most of the lithium bearing pegmatites are right around Plumbago Mountain, right? And so that they seem to be kind of really restricted to that area. So I can't totally say in total confidence that you're not going to find any further out, but I think the further you move away from that, maybe the less likely you are to encounter them. But I have no idea what's going on at depth. You can only see what was exposed at the surface,
Right.
and you also don't know what used to be there above you that has been wiped away by a glacier and then just erosion. So
Interesting.
yeah.
Somebody to that point asked, how deep underground are the deposits at Plumbago? Do we know that, or would that take further, like you were mentioning before, drilling cores?
Yeah, it would take a more intensive core drilling program to figure out what's going on in the subsurface. Yeah.
Any potential for radiation exposure from this mining this stuff or quarrying this stuff?
No, not that I know of.
So Senator Bennett was asking, do you think the definition of metallic mineral should be changed in Maine law? If so, how? I think you alluded to that at the end.
Yeah, I don't know. I can't really comment on that. I think that's Senator Bennett. I think that's up for you guys to decide. But I think maybe the heart of the issue is what exactly is it with each mineral deposit? Maybe looking at them differently, or just consider looking at them differently and be like, what is it about each mineral deposit what are the risks associated with that particular mineral deposit? And if it's certain mineral deposits that are more chalcophilic, they have metals in them that are more sulfur loving, maybe it's the sulfide minerals that are the ones that are really troubling. I mean, if we look at where the mining laws were put in place, really it was really as a prevention for or not to prevent. I shouldn't say to prevent, because it's not there to prevent. But they were there with base metal mining in mind. So the Callahan in Harborside and Blue Hill, those deposits, which are completely different than granitic pegmatite deposits, they host those sulfide minerals there, right? And so one was a super fun site, the Harborside mine, and not just because of the metals there, but also because there were PCBs that were spread out over the area, and that's something that's generally not discussed. And so polychlorinated biphenyls, they were spread out over the site, and so that's another reason why it was a super fun site. And I believe that may have even been the red flag there that set it all off. But these old but those are a specific type of deposit that I think when they went into making the mining laws, that's the current mining laws, that's what they had in mind. And so there's a specific mineralogy associated with those deposits, and maybe looking at that, what is it about that particular economic deposit that's different than the spodumene deposit in Newry, or the rare earth element deposits in northern Maine, or potential antimony deposits in eastern Maine. So it's looking at each different deposit type is maybe an approach. I don't know. That's up for the legislators to decide on this. And I encourage you, Senator Bennett, as well as your colleagues, to really confer with experts that have knowledge about individual deposits and of course environmental impacts of specific deposits, and do the due diligence there.
Great, thanks. That's I think going to be the big question going forward. And I thought that was a great answer, Miles. We need to do more due diligence and understand what the impacts of these different areas are. We have Couple more quick questions.
Yeah.
Somebody asked, well, somebody suggested that existing coring suggests the pegmatites are 100 to 300 feet thick. Just to kind of stitch back to that question. Real quick, does Norway, Maine have lithium deposits? Is there something, or did you just put Norway on that map to?
Oh, yeah, no, I put for, I figured everybody here would know where Norway is with the CV. So just for context is why I put that there. No lithium deposits that I'm aware of in Norway. However, there are granitic pegmatites in, like I said, all over Western Maine, coastal Maine. You will find them in Norway as well.
Mhm. The question I lost earlier was about graphic granite and
Oh.
wondering how that formed.
Oh, interesting. Yeah, so graphic granite. So it's you got a melt that should be crystallizing, but it hasn't yet, and then something that kind of sets it off, and you get this interesting skeletal growth between. Here I have. I'll go. You get this interesting skeletal growth that forms between the feldspar and the quartz. And I had it right there. So there's the graphic granite right there. So it
yeah.
has this interesting kind of cuneiform type texture right there. So again, it's this intergrowth of the feldspar and the quartz. And so in an undercooled melt, you might get this. You find it only in granitic pegmatites too. So it's specific to granitic pegmatites.
Okay, one more question, and I think we can wrap this up. Chris asked, he said, we have a private quarry with massive schorl. Would it be worth looking for something worthwhile there? It's near Auburn.
Oh, I don't know. I haven't visited the site, but I mean, if you have schorl, that's an indicator that there's some enrichment there, particularly with the boron. So, but what you might find, I don't know. There are schorl is the most common tourmaline in Maine, and you find it in a lot of pegmatites, particularly in Western Maine, and you find it in some granites as well and schists. So it could mean something, it could mean nothing.
Right.
But I encourage you to check it out.
Well, thank you so much, Miles. Other than that, there's just been a ton of kudos for your presentation, and I really appreciate just some good, solid information about what's out there, and hopefully people will proceed with caution and with more information at their disposal. So thanks again for coming, and hopefully we'll get a lot of folks out to the exhibit that you're going to have up there. And
no, definitely. And I encourage folks that if they have more questions after this, if you're like me, I have a million questions after the fact. Please feel free to reach out. Open door, communicate with a communication here. So
sweet.
Got an email. Yeah, I had one at the bottom, so I'll just kind of go really quickly back through.
I know he's easy to find on their website, on the Maine Mineral and Gem Museum website.
Yeah, you can find it there as well. So yeah,
it's a funny picture of him that
I know. I know that relic. Oh my gosh. Maybe I got to get you for another photo shoot here there, Scott.
All right. Well, I'm game. After the Climate Convergence, again, hoping everybody thinks about coming to the Climate Convergence to continue this discussion and lots more about our bioregion and how we can become more resilient to the climate crisis that's upon us. So thanks everybody for coming, and we'll see you soon.